Are you ready to take your system administration to the next level with Automic Automation? We are modernizing your daily operations by bringing core administrative tools directly into your workspace. Integrated database maintenance. Proper database maintenance is essential for keeping your systems highly performant, running efficiently, safely, and reliably. Traditionally, robust database maintenance often required additional utility installation, configuration, and direct database access. By integrating these core functions directly into the Automic Web Interface and the AE REST API, Automic Automation breaks down barriers, significantly reduces administrative effort, and makes database maintenance accessible to everyone. Before we jump into the interface, let's look at the database maintenance flow. Each step builds upon the previous one, ensuring your database stays clean and prepared for ongoing operations. Let's walk through how to execute these steps. The database maintenance flow begins using your existing operational data. First, archive datasets and archive flag on relevant records. If needed, Reset Archive Flags clears these flags so you can safely restart the process. Then, the revision report generates a comprehensive, downloadable audit trail. Next, Reorganize Data reviews those archived records and applies a deletion flag. To take a step back, Reset Deletion Flags clears the deletion flags, keeping operations governed. Finally, Delete Data permanently removes all records marked for deletion. Let's start with the database maintenance in the Automic Web Interface. Whether you're a seasoned database administrator or a general system administrator, this seamless integration empowers you to keep your systems clean using the intuitive interface you already know. Let's look at how you manage these tasks directly from the client's list. Automic Automation introduces a streamlined workflow, starting with archiving operational data. This critical first step preserves your data by setting archive flags on eligible records. Once triggered, you can instantly track the operation in the client history under the specific CLNTARCH task type. It is as simple as that. From there, you can open the corresponding report to securely review the details and even download your archive data right from the interface. If you ever encounter an issue or simply need to make an adjustment, the Reset Archive Flags option lets you safely step back. This operation clears the archive flags from your records, resetting them to their default values so you can safely repeat the archiving process. You maintain complete control, with every single adjustment securely logged in your history for full transparency. Before moving forward, you can generate revision reports. Just set your date and time range, choose your content types, and configure any optional archive settings to refine your data. This critical audit step creates a comprehensive list of all objects that have been created, modified, imported, transported, or deleted. You track this operation in your history under the CLNREVR task type. By opening the report, you verify your exact data state, and you can easily download it for your records, confirming your actions with total confidence. Next, we seamlessly move to reorganizing operational data. This crucial step reviews your previously archived records and officially marks them for deletion by setting deletion flags. You can easily monitor the progress of this operation in the Client History tab under the CLNTREORG task type. By opening its specific report, you can verify exactly which records are now queued for removal. And if you need to step back, the Reset Deletion Flags option is right at your fingertips. This corrective action clears the marks and is automatically recorded in your history, keeping your operations safe and governed. With everything safely organized, you are ready to delete operational data. This operation physically and permanently removes all data records that have both the archive and deletion flags set. If you have already worked with Automic Automation's DB utilities, you'll recognize how this mimics their exact, safe behavior. Tracked under the CLNTDBDL task type, a quick check of the report confirms exactly what was successfully removed, freeing up space and giving you total peace of mind. You have just performed complex, end-to-end database maintenance without ever leaving AWI or typing a single command. Beyond the core lifecycle, another important maintenance task is emptying the recycle bin. This action physically and permanently removes objects that have been independently deleted from the system, not using the delete data option. Tracked under the CLNTEMRB task type, the report completes your audit trail for this specific cleanup. Now let's see the AE REST API implementation. If you are an automation expert or integrating Automic into a broader CI or CD pipeline, you can reap the full benefits of the AE REST API. It empowers you to execute the exact same maintenance lifecycle using standard REST requests. This allows you to modernize your operations by replacing legacy OS jobs with REST jobs, seamlessly integrating this new approach into your existing automated maintenance schedules. To understand how to configure these requests, our comprehensive Swagger UI documentation is your go-to resource. You can easily explore all available endpoints such as those for revision reports, reorganizing, or deleting data. The documentation provides the exact JSON schemas you need, allowing you to easily look up how to pass specific execution parameters and perfectly mirror the capabilities found in the AWI. To see the real power of this integration, let's look at an example of how you can leverage the REST API directly within AWI using standard REST jobs in a workflow. The main benefit here is reusability. You can seamlessly replace the legacy OS jobs that ran the utilities with these REST jobs. This allows you to completely reuse your existing database maintenance workflows, integrating them perfectly into your established maintenance schedules. This workflow automates archiving, reporting, and reorganizing data processed through a single REST agent. When the workflow is executed, it triggers both the archiving process and the revision report to maximize efficiency right from the start. This parallel branching allows the system to handle these operations independently. Once both processes end successfully, the data reorganization job is executed. Let's break down exactly how it operates step by step, focusing on the REST API endpoints driving the process behind the scenes. The first jobs triggered are Archive Client Start and REVR Client Start. The Archive job sends a POST request to the Archive Data endpoint. Simultaneously, the Revision Report job sends a POST request to the Revision Report endpoint, passing a specific JSON payload via direct input. A key part of this payload is the types array, including items like access, cancel, create, delete, restore, and so on. Both system responses are captured as Archive Run ID and REVREP Run ID respectively, and are passed to the workflow so downstream jobs know which executions to reference. In the process monitoring, we see both start jobs are executed. Next in line is the Archive Client Download job. Because archiving takes time, this job uses a status check include to wait until the archiving process finishes successfully. Once the server confirms it is ready, the job sends a GET request to the Revision Report endpoint using the Archive Run ID. This retrieves the newly created client archive zip file and downloads it directly into the temp folder on the machine where the agent is running. Following the exact same waiting logic as the top branch, the REVReport client download job waits for its predecessor to finish. Once the report is generated, it triggers a GET request to the Revision Report endpoint using the Revision Report Run ID. This pulls down the custom-named report zip file, saving it alongside the archive in the temp folder of the machine where the agent runs. In the process monitoring, we see both download jobs are executed. The last job, Reorg Client Start, acts as a critical dependency checkpoint and waits for the successful execution of all of its predecessors. It will only trigger once both the archive data and the revision reports have been successfully generated and downloaded. Upon meeting those conditions, the job sends a POST request to the reorganization endpoint. This final API call reorganizes the operational data by setting the necessary deletion flags. With the database successfully reorganized and all files safely downloaded, the process reaches the end node, safely ending the workflow. In the process monitoring, we see the reorg job is executed and the workflow ends. Take advantage of these new, integrated tools to handle your core database maintenance and ensure optimal system performance, all while maintaining the security and flexibility of our standalone database utilities for highly specialized tasks. Reap the benefits of integrated database maintenance and take your operations to the next level. To learn more about these features and how to configure them, visit our product documentation. Thank you for watching.